Good morning, guys.
Morning.
Good. Okay, now before I start, any questions about power and intensity
No.
and their relationship? And intensity's relationship to area. Any questions about wavelength? And or its relationship to whatever we talked about so far. Yep. Okay. Good. Then we can go on to this, okay, what we call amplitude. Yeah, okay. Which mainly is okay, is going to be as okay the bigness of the wave. Okay, now let's just check a wave. Let's say it's okay. Now you may see drawing this line here, it's okay again and again and again and again. And we can mean it's okay, just say that this is going to be as okay, the average line, or average level. So now, okay, yes, if we said that this here was a wave. Yeah, okay. Now I hope that all of you, yes, okay, will agree that from here to here, if we measure in time, will be period. Okay. Whereas, okay, yes, if this here is measured in length, that would be, yes, okay, what we call wavelength. Yep, okay. Now, the way that they define amplitude is going to be as okay, either from the average to the peak, or from the average to the trough. Either of these will be as okay the amplitude of this wave. Did you guys get that? So either 1 or 2. 1 or 2 will be as okay the amplitude of the wave. Did you guys get that?
Yeah.
Okay. Now, guys, as I have been saying, okay, now you can have as okay a wave with the same wavelength or period, okay, but with okay as you can say it's okay different amplitudes. Yeah, okay. Likewise, okay, you can have waves with the same amplitude, but then it's okay with different periods and wavelengths. Did that make sense? Okay, so what that mainly is okay establishes it that okay, yes, period and wavelength. And even yes again says okay, and even yes okay frequency, because okay, these three yes okay are related together, but they are not related to the bigness parameters. Is that clear? Did that make sense?
That says period, wavelength, and frequency are not related to the bigness parameter.
Parameters.
Okay.
What were your bigness parameters?
Amplitude,
power,
power, intensity,
and amplitude. Okay. Did that make sense?
yeah.
Okay. Because, okay, what did we have? We have waves with the same periods, which means, okay, give them, yes, okay, the same wavelength, right? Okay. But, and okay, since they have the same periods, they will also, as okay, have the same frequency. Clear? Okay. But what we see is, yes, okay, we have a light purple wave and we have, okay, as a light green wave. They both have different amplitudes, although yes, okay, they have same period, wavelength, and of course, and frequency. Likewise, what we see here is okay, the dark green wave, and okay, it's the pink wave. Okay, they have different wavelengths. This is the wavelength of our dark wave, dark green wave. This is the wavelength of the pink wave, which we can say, okay, so but we measure this in time, and this in time, that would be the periods. So they have different periods and different wavelengths, and of course, okay, there will be different frequencies then. Okay, but they end up having as okay, they have the same amplitude. So you can say, okay, changing your period or wavelength or frequency is not going to just okay affect the bigness parameters, or vice versa. Clear? Okay, so if one changing one doesn't affect the other, that's mainly because, okay, they are unrelated. Clear?
Yep.
Good. Okay. Now, guys, let's just go in again and say it's okay. For instance, this is one wave. Where we mean is okay, you can say it's okay. This here will be the amplitude, or this here will be the amplitude. Okay. And we can say it's okay, we have an other wave. Let me just choose a, which for me is okay, say, for instance, this one. Yeah, okay. And we can mainly, it's okay, say that I says, okay, this will be the amplitude, or this will be the amplitude. Okay, so what we mainly can see here is that, okay, yes, this wave here, yes, okay, has a smaller amplitude. Whereas, okay, it's our dark green wave. Yes, okay, what does it have? It has, okay, it's a greater amplitude. Yeah, okay. What we call, yes, okay, this like purple wave here, you have, okay, has a smaller amplitude. Is mainly, yes, okay, because it has, or it carries less energy. So I will have a lower power. And since it has a lower power, that's okay, it will have a lower intensity. Whereas, okay, the reason that, okay, it's our green wave is bigger is mainly because it has or carries more energy. So it's going to have, okay, it's a greater power. And since it has a greater power, that's going to mean that, okay, it has a greater intensity. Did that make any sense?
Yep.
Okay, so what does that tell us? That means that's okay, it tells us it's okay what the relationship between power and intensity and amplitude is. Which, to begin with, guys, mainly or mean that, okay, yes, that we can say is okay, that power is directly proportional to intensity. Right, okay, which is going to be, it's okay, directly proportional to amplitude. Yeah, okay, which mainly or mean that, okay, yes, if the power increases, the intensity will increase, and if the intensity and power increases, it's okay, the amplitude will increase. And that's okay, where we have, okay, as a dark green wave, for instance. Okay. Whereas if you go the other way and say that power decreases, that's going to cause a decrease in intensity, which means you'll call that, okay, as your wave has a lower amplitude. That's that. Clear? Did you guys get that?
Yeah.
Yes.
Good. Any questions so far?
No.
Okay. Now I know, okay, that this relationship here is not just, okay, let's press, okay, fully documented as I have written it here. Okay. Yeah, okay, that's going to be as okay, something that we add on to it, but we'll come back to that in just a little bit. Okay. Now, guys, okay, as when they talk about as okay, the unit of your amplitude. Okay, now the unit of amplitude, or we can say, okay, the amplitude can be as okay expressed in any of the 3 units of your acoustic variables, which was pressure, which was density, and which was distance. Yeah, okay. So pressure is okay, that could be as okay either Pascal, or as we say, it's okay newtons per, let's say it's okay meter square, for instance. Density was okay as kilograms per liter. And distance, yes, okay, would have been okay as any unit of distance. We can say it's okay, meter, centimeter, whatsoever. Is that clear? So either of these 3 here is okay, can be used to just okay express the amplitude. Did you guys get that? Okay. But mainly, guys, because amplitude is more of okay, because it's okay, a relative term. That's why it's okay is going to be expressed in okay as a more relative unit, which is going to be decibel. Okay. Now decibel is a unit that we will come across again and 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 again in this course here. Okay. Now the symbol for our decibel is going to be a lowercase d as in dog and an uppercase B as in boy. Is that clear? Okay, so whenever it's okay, you want to write the word decibel, it can also, as okay, just be symbolized by this symbol here, dB. Now, guys, let me ask a question. Before starting this course here, and if I say it's okay, what is the relationship between sound and decibel? What would you guys say? Have any of you ever heard of the word decibel before? Okay. So anybody who heard of the word decibel, would you mind telling me what you know about it?
I just thought higher decibels meant more sound.
Okay. But please, 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 please. In this course, yes, okay, decibel is going to mean something pretty different. Okay. Decibel here is going to be used as a relative term. Okay. In regular, as okay, I mean, we talk about sounds and decibels. You made it as okay, the louder the sound, the greater the decibels. But this is not what we will use, or this is not what decibel is going to mean in this case here. Okay. Okay. So decibel in this course here, guys, is going to be as okay, a relative term. Okay. And let me just, okay, try to just, okay, make it as simple as it is. Because whenever we talk about as, okay, I use the unit decibel, it's going to be as, okay, a relationship or a comparison between what we started with to what we end up with. Did that make sense? Clear? Okay. So you can take that in any ways. You can say as, okay, I started my day with having $200 in my wallet. Clear? Okay, that's the amount that you start your day with. By the end of the day, I'm only left with $2. Did that make sense? Clear? Okay. Okay. But now, yes, okay, this is, yes, okay, these two numbers here are going to, yes, okay, be expressed in terms of decibels. So it mainly says, okay, I'm left with 100 at the end of the day compared to, yes, okay, where I started my day with. So, okay, you're left with 100 of what you started with, right? You start with $200, you're left with $2. Did that make sense? Clear? Okay. You can go the other way around and say, well, okay, well, I started my day with $2 and ended up with $200. And then you immediately will just say, it's okay. I left with 100 times more than I started with, right? Okay, so that 100 times more is decibels. Or will be expressed in terms of decibels. Okay, guys? So throughout this course here, anything that's going to, yes, okay, be expressed in terms of comparing, yes, okay, what you start with versus what you end with can be measured in decibels. Did that make sense? Any questions? Okay. Okay. So throughout that's going to be as okay when you will see that's okay decibels being used again and 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 again. That's comparison between, yes, okay, what do you have at the start? What do you have at the end? That comparison is going to be expressed using the unit of decibels. Did you guys get that? Good. Now, guys, as far as the typical value of your amplitude, Hakuna Matata, don't worry about it. Okay? Okay? So don't worry about that. Next comes what determines your amplitude. What's going to, yes, okay, determine your amplitude of your sound wave. Now, if you look at the relationship, you can want to say it's okay. That okay, yes. We can say it's okay, power output, which was this knob here, right? Yeah, okay. We said that, okay, yes, if we turn it clockwise, it's okay, that's going to increase. So what was that going to do? That was going to, it's okay, because it's okay. leads to, yes, okay, an increase in power, which is going to, yes, okay, lead to an increase in the intensity, which is going to, yes, okay, lead to an increase in the amplitude. So just like power was controlled by your power output, which also, yes, okay, ended up controlling your intensity, likewise, they're going to, yes, okay, control your or determine your amplitude of the wave. Whereas, okay, yes, if you went the other way around, because these were all directly proportional to one another. Clear? Okay. So yes, okay, the control of your amplitude is controlled by the power output, which sets the power, which sets the intensity, which yes, okay, determines the amplitude. Clear? Okay. But what it also says is, well, okay, yes, just as, okay, yes, a sound wave where, okay, yes, a certain power, amplitude, or intensity travels through tissues. Yes, okay, the power will decrease, the intensity will decrease, and so will the amplitude decrease. Did that make sense?
Yep.
Good. Okay. Okay. And as I said earlier, yes, okay, when we talked about power, when we talked about intensity, that here is okay, the source is going to be as okay, the ultrasound machine, because that's where yes, okay, you actually yes, okay, have this power output control knob. Clear? Okay. So that's okay, what the initial power is going to be. Okay, that's mainly yes, okay, what you set by the system, which is going to just okay, be as okay, having a direct relationship to the intensity, which is going to just okay, cause or directly as okay, affect the amplitude of the wave. Did you guys get that? Okay, so you're okay. So what we mainly can say here is that sorry. You can say that the initial power, likewise, okay, the initial intensity, and okay, yes, your initial amplitude. All that was okay, yes, determined by the source or your ultrasound machine. Whereas, okay, yes, at some end here, yes, okay, we will have, okay, because it's okay, there's going to be, yes, okay, a final, you can have, okay, a final power. You can have a final intensity. And likewise, okay, you can have a final amplitude. Is that clear? Right, okay. And what we as okay should know is that okay, yes, sorry, that okay, this initial power, intensity, and amplitude is always going to be greater than the final power, intensity, and amplitude. Why? Because as we said, that these three parameters here are going to decrease as they travel through the tissue. Did that make sense?
Yeah.
Right, okay. And now what I said earlier, comparing, the initial, PIE to, the final PIE. Is going to be okay. How can I write comparison? Okay. Comparison is going to be expressed in terms of decibels. The details of all this will be further in chapter number 6. But since we know that as the power will decrease, the intensity will decrease, and so will the amplitude decrease. Initial power is always going to be greater than the final power. Initial amplitude is always going to be lesser than or greater than the final amplitude, and the initial intensity is always going to be greater than the final intensity. As sound waves travels deeper and deeper and deeper and deeper through tissues. Did that make sense?
Yeah, so and then you said when you're comparing the initial and
So that's
final.
going to be expressed in in terms of decibels. Yeah, okay. Last question, but we have already answered it. Is amplitude adjustable? Well, yes. Of course it is, just like power was adjustable, just like intensity was adjustable by adjusting your power output. How? Well, here it is being by turning on a knob. Did you guys get that?
Yep.
Sorry, any questions so far? Okay, guys. Now, so when we took a wave, again, back to the beginning. We took a wave like this. This was our wave. Clear? Okay. We said this here is in time will be the period. Okay. We can also wrapping is the duration. The duration of one cycle, okay? We can say it's from here to here as well. It's in distance or length That would be is okay, what we technically is okay called the wavelength. We can say as okay. Now from here to here, we said 1, or here to here, 2. So 1 or 2, okay, not both. That will be as okay the amplitude of the wave. Yeah, okay. Whereas if we say 1 and 2, now that's going to be as okay what is strange enough as okay called as okay peak to peak amplitude. Maybe okay, so we say okay, well okay. This is okay was the peak of week 1. Okay, all is okay, we call it okay, this is the trough of the wave, but we can say okay, that's going to be as okay the maximum negative peak of peak 2, or wave 2, sorry. Clear? Okay. So if we take as okay, we can say okay, from this level to this level like this here. Or if we went as okay from here to here, that's going to be as okay what they call is okay the peak to peak amplitude. Okay, guys. Although it's okay, this here is okay is the actual amplitude. Or this here is okay is the actual amplitude. Did you guys get that?
Yep.
Yeah.
Okay, guys. Now, so far, is there anybody who is in the least doubt about the relationship between our 3 bigness parameters? Have you said that, okay, yes, they were directly proportional, which mean if one increases, the other will increase, and the other will increase. Or if you go in the other direction, if one decrease, then the other will decrease, and so will the other decrease. Clear? Any doubts?
No.
Okay. Now, guys, you guys may start hating me from now. But I briefly mentioned, says, okay, this relationship is not completed yet, because the actual relationship is going to be this. Did that make sense?
Can you repeat that?
That the actual relationship between power, intensity, and amplitude is, well, okay, they are directly proportional, which means that, okay, when power increases, the intensity will increase. When power increases, the amplitude will increase. Likewise, when the intensity increases, that's because the power increased. When the intensity increases, that's because the amplitude increased. Or the amplitude is going to increase because power increased, and amplitude will increase because the intensity increased. Did that make sense?
Yeah.
Okay, but what did I do? It's going to be power is directly proportional to intensity is directly proportional to amplitude square. Did you guys get that? Did you guys get that?
It's just going to be amplitude squared?
Exactly.
Okay.
Now, what would that mean? Let's just say that, okay, let's just take an example and say that, okay, the amplitude increases twice. Is that clear? So if your amplitude doubles, and then they ask you, yes, okay, what is going to be, yes, okay, the change in your power, what is going to be, yes, okay, and or what's going to be the change in the intensity. Did you guys get that? Now, that's okay, there should be no doubt, mainly because, okay, we says, okay, increase says, okay, of course, that's okay, the power and all the amplitude also says, okay, increase because the amplitude increased. But we said that, okay, the power, that's okay, the amplitude increased twice. Clear? Okay. But that is going to, yes, okay, but the square of that is going to be as okay, the change in the increase in the intensity of increase in the intensity and okay, and all is okay, increase in your power. Okay, so the question mainly is okay, what is 2 raised to the power 2 going to be? That means it's okay, just means 2 multiplied by 2, which we actually just okay becomes 4. So that means it's going to mean that okay, yes, the intensity will increase 4 times. And your power will increase 4 times if the amplitude doubles.
So if the amplitude increases in general, like it's gonna increase by 2?
No, let's take another example.
Okay.
Let's say that okay, yes, the amplitude increases 3 times.
Oh, then it would just be 3 squared.
So that's going to be 3 squared. And what would that mean? 3 times 3, which will become 9. So in that case, that's okay, your power will increase 9 times, and so will the amplitude increase 9 times. Did you get that?
Yeah.
Good. Whereas, okay, on the other hand, we said that, okay, as your amplitude decreases to half. Okay, what you mean is, okay, so we started off with a wave with a big amplitude, but it's now reduced to just, okay, half its size. And the mean is, okay, we'll just ask us, okay, what's going to be the change in the intensity, or what's going to be the change in power? Now, this is going to be as okay. Now, since it's okay, you see that amplitude is going to be squared, that means okay, mean that okay, half multiplied by half, which mainly will mean 1/4. So your intensity is going to reduce to 1/4. And so is the power going to reduce to 1/4.
But they would all equal the same thing though.
What do you mean?
So you have 1/4 for power, 1/4 for intensity, and technically 1/4 for
No,
amplitude.
no. Your intense amplitude just reduced to half.
But it's still squared.
But that square is just okay in terms for the relationships. Had it been the same that, okay, as they were all had been square, right? Right? Then there was probably no point of putting the square. It would have been the same, right? Did that make sense?
So the square is just there.
That's how the relationship is finalized, yes.
Okay.
Clear, okay. Whereas, okay, on the other hand, if we say that, okay, as the amplitude decreases to, let's say, it's okay, 1/3. And you ask, okay, and what's going to be is okay, the decrease in the power or the decrease in the amplitude or intensity, sorry. That's going to be the square of 1/3. And what is the square of 1/3? It's going to be 1/3 multiplied by 1/3, which becomes 1/9. So your power and intensity is going to reduce to 1/9. Did you guys get that?
So your amplitude is still just decreasing by 1/3?
Mhm.
Okay, and then the other two would be by 1/9.
Exactly.
Okay, one more question. So if power increased by 2,
Mhm.
and intensity is going to increase by 2, and then amplitude, oh, I guess.
No.
I mean, amplitude would increase by 4. No.
Let me put it this way, my dear. You can say that, okay, as the change in power, where that is increasing or decreasing, is going to be equal to the change in power and intensity, whether that is increasing or decreasing. Did that make sense?
Yeah.
Okay. Okay. But those changes in power and intensity is going to be the square, or it's going to be equal to the square value of change of the amplitude. Clear? Okay. So you can mainly say that, okay, yes, the change in amplitude, whether that is increase or decrease, is lesser compared to the change in power and intensity, which is going to be greater increase or greater decrease. How greater? Mainly as, okay, just the square of the change in the amplitude. The square value of, yes, okay, the change in the amplitude is going to be the change in your power and intensity. Yeah, okay. So what I said was that, okay, yes, if your amplitude increases twice. Clear? Okay, that you actually have a wave which is twice the size that it was. Okay, that's because amplitude increased twice, right? Okay. Did that make sense?
Yeah.
Okay. Okay. But what would that mean? Oh, that's okay. The question would then be as okay, but how much change did you have in your power? How much change did you have in your intensity? To get that, that's where you have to square the value by which the amplitude changed to get that. So the square of 2 mainly means 2 multiplied by 2. Or simply saying it's okay, when you're squaring any number, you're just multiplying it by itself, right?
Yeah.
Did that make sense?
Yeah.
So when we say that, okay, yes, so that's going to be, yes, okay, the amplitude only doubled, but the change in the intensity is going to increase 4 times. So is the change of the power going to increase 4 times.
But what happens if power and intensity increase? If like what are the other increases? What happens to amplitude?
Never increases what, my dear?
So if power increases, then amplitude increases. If intensity increases, then amplitude increases.
That's what we mean by being directly proportional, right?
Right. What does it increase by though?
Yeah. Can you do an example like that?
Okay,
That's where
listen.
I'm
Now
confused.
we're going to have questions in the chapter or in the exam review. Okay, clear? Okay. Well, okay, I can try to look one up, but you can mean it's okay. Just play around with the numbers. Let's see. Okay, listen, guys. Let's do this right here. Let's say that we can say it's okay. The power of a sound wave is 2 watts. Yeah, okay. Now we can say it's okay that the amplitude of a wave is okay increases from 6 to 12, whichever unit. Clear? Okay. Now the question is going to be is okay, what is the final power? Did you guys get that? So what do we have is we have okay as a power of a sound wave which is 2 watts. Okay, we can say it's okay. This is we can in this case say okay, that's going to be it's okay the initial power. Yeah, okay. Let's say it's okay. Now what this 2 watt here is going to is okay have is going to is okay have an amplitude that was equal to 6. Did you guys get that? Right, okay. But what they say here is okay as that the amplitude of the wave increases from 6 to 12. So we can say okay, this is the initial amplitude. This is the final amplitude, which is 12. Did you guys get that?
Yeah.
Good. So what happened here to your amplitude? From it getting to yes, okay, from 2 to 12, what happens to the amplitude?
It doubled.
It increases by 2, right?
Yeah.
Good. And our question now is, okay, as what is going to be as okay our final power? And of course, that's going to be in watts. Now, what we said here is, okay, that the power, the amplitude increased twice. Clear? It doubled from 6 to 12. Is that clear? But our question is going to be as okay, we can say, okay, well, okay, let's just say, okay, how many times is it that the power is going to increase? Now, to get that, that's when you go and say, okay, the change in amplitude has to be squared to find out what we were right or what the change in the power is going to be. Did that make sense? So the square of 2 means square of 2 means 2 times 2, which is 4. So that may mean that, okay, yes, our power will increase 4 times. Did you get that?
Yeah.
Which means it's going to be as okay, as simple as 4 multiplied by the initial power, which will end up with a final power of 8 watts.
Okay, I'm gonna ask my question in a different way. Because, like, I get this. This is kind of what we were doing before. But so would there ever be a question that's like the power is like goes from 2 to 6? What's the final? And then the amplitude is 6. And then you have to find the final amplitude, I guess is what I'm asking. Like, if you're given the power or intensity, like the initial and the final, is
Mhm.
there going to be a question where we have to find the amplitude? Teresa, am I asking that right? I know you have the same question.
Yeah, yeah, like if you're given power or intensity, like if power or intensity increases first, what does amplitude increase by?
Okay.
Right. So this exact like you could do it the same way.
Okay.
The power
No,
is
no,
no. So it would just be we'd be
pretty much
given
this.
power or intensity, and we're finding the final, or no, we're giving the amplitude.
Yeah.
We'd have to find the power or intensity. Thank you.
Okay. But again, it's okay, as I said earlier, be watchful, guys. Because it's okay, we may say, well, okay, we had a power of, let's say, it's okay, 6 watts. Clear? Okay, we had a power of 6 watts. It increases 4 times. Clear? Clear? And we
Yeah.
had, okay, as an initial power intensity of 6 watts per centimeter squared. So what's going to be the final intensity? Okay. Yeah, okay, yes, the change in intensity is equal to the change of power. It's only as okay when you want to compare as okay the change of amplitude to the change in intensity that you have to just okay square the value that the intensity changes, not amplitude changes, which then will be as okay the times that your power changes, whether that is increasing or decreasing. Did that make sense?
Yep.
Clear, okay. So either of these, or we can even yes, okay, because we actually just made this up by putting all the relationships together. Or we can make this just do it this way and say that power and intensity directly related, no squaring, no cubing, nothing. Did that make sense? We then said that yes, intensity is directly proportional to amplitude, but that would be amplitude squared. Likewise, we also hence can say that yes, power is directly proportional to amplitude squared. Now, what I hope all of you as will understand is that yes, directly proportional may mean that yes, if any of these here is were increased, there's going to be an increase in the other one as well. Or if one decreases, the other one is going to decrease as well. Yeah, okay. But where we can mainly says that there will be if you go decrease, there will be a greater decrease in power compared to the amplitude. Likewise, there will be a greater decrease in intensity compared to amplitude. How much? The change in power is going to be equal to the square of the change in amplitude, where that is increasing or decreasing. Whereas, when we talk about the change in power related to intensity, there's going to be an equal increase. And likewise, that's an equal decrease. So we can say if the power is increased twice, well, so is the intensity going to be increasing twice.
Mike, if amplitude isn't squared, is it still proportional to intensity and power, or is it always going to be squared?
It's still directly proportional.
Okay, so is it always going to be squared, or
it's always going to be squared?
Got it.
Yeah, okay, and that's why I said back here as that as we have established that increase in one is going to cause increase in the other is going to cause increase in the other. Decrease in one is going to cause decrease in the other is going to cause decrease in the other, which were directly proportional. Yeah, okay, and I said it that yes, but this relationship is not fully documented yet. Why? Because at that time it's I hadn't added the square. Did you guys get that?
Yes.
Okay. So the actual relationship is that power is directly proportional to intensity, which is directly proportional to amplitude squared. What we mean by being directly proportional, there should be no question about it, guys. If one increase, the other two will increase as well. If one decrease, the other two will decrease as well. Clear? Okay. The square thing is that the change of power is going to, you can say, is okay, equal to the square of the change in amplitude. Did that make sense? The change in intensity, up and down, is going to be equal to the square of the change in amplitude. Okay, you can go on and say, yes, okay, what if amplitude is reduced to 1/4? Then you just go, yes, okay, that's going to be 1 over, because 1 multiplied by 1 is 1, right? So that's okay, what is the square of 4? It means 4 multiplied by 4 multiplied by 4 multiplied by 4. So 4 multiplied by 4 is
16.
multiplied by 4. We are looking towards just, okay, quite a number, right? No, sorry. Okay, 16 times, sorry. No, sorry, my mistake. 4 multiplied by 4, sorry. I probably went bananas. I was carding it, sorry, guys. So that's okay. The power will change 16 times. Clear? Okay. So if amplitude is okay, increase 4 times, the power will increase 16 times. Did that make sense? Likewise, that's okay. No. Whereas if you go decrease, well, okay, as if amplitude decreases 4 times, then intensity of power is going to reduce to 1/16. Did that make sense? Okay. Change. Now, let me teach you guys a little bit English. Change can be yes, okay, in any direction. Okay, if I say, okay, change your behavior, yes, okay, you can improve your behavior or it can get even worse. It can go in whatever direction, right? Okay. Here. Right, okay. But if I say, yes, okay, improve, then okay, as I fix the direction, I say, well, okay, it's not just a matter of changing. It's okay, I want you to improve. Right, okay. Or yes, okay, in other ways around. Okay, so change is a more yes, okay, generalized term, as it says, okay, increase is going to be specific. Decrease is going to be specific. Okay. Another term that you may see as okay be used in the books is going to be enhanced. Now, what does the word enhance mean? Enhanced, ENHANCED. If we go in past tense, I'll just the D and okay, yes, enhance.
Like more detail, more. All right.
So what will more mean?
Enhance is like amplified.
Amplified, so increasing, right? Right? So what will be an opposite of enhanced then? Reduce. Okay. So that's okay, guys. You will see it's okay the play of words in your questions. Yeah, okay. Okay, guys, but is there anybody who has the least doubt about the relationship between power, intensity, and amplitude? They are directly proportional, but it's just going to be squared with the amplitude. That the value of the change in the amplitude is going to be squared to determine how much change that will happen in the power and intensity. Any questions? Now, let me ask a question then. What can cause power and intensity to become inversely proportional? What may make power and intensity inversely proportional?
Is that area?
Area. Yeah. Did we say that area is inversely proportional to intensity? So although that's okay, the power may, that's okay. Increase by, that's okay. If the change in area is greater than the change in power, then your intensity will become inversely proportional to the power, right? OMG. Some of you just look lost.
It's just a lot all at once to absorb. It's just look, it's a
Don't get a
lot.
crazy face for that.
No, but listen, dear. Okay. So, how many words can you absorb in a day?
I've never tallied how many.
Okay. Let me put it this way. How many pieces of new information can you absorb in a day?
I don't know.
You don't know. Okay, dear. Maybe I should ask it this way. Do you think I'm going too fast?
I don't think you're going too fast. I think that it's just a lot to absorb. It's newer, at least to me personally.
Okay.
It's new, so it's
Mhm.
Not
just
just memorization like anatomy
yes.
and phys. This is like all application, and there's a lot of random numbers we have to remember.
Which
And even
random number?
studying after class every what?
Which random number?
The
What's
typical
the typical range of
values.
ultrasound frequency?
Yeah, that's
2
in the
to
table.
15. Just think of, okay, yes, the day after Valentine's Day. 2:15.
Then there's units with
Huh?
all of it. And there's units.
Units. I
Yeah,
gave the unit. Okay. Which units?
there's just a lot of units for all of the different parameters.
Okay.
All
So
we're
my
saying is it's a lot of information. That's all.
okay. So do you guys want more time? That's my question. Well, guys, I'm okay. I'm giving you guys, okay, as an hour for lunch. To really take an hour to, yes, okay, make whatever you make and eat it. Just asking, dear. Nobody's been put in the spot here. Okay, to toss, okay, as a tea bag in a cup and pour some hot water on it. That's not going to take 15 minutes. And you can sip during the class, I don't mind. Okay, guys? So what can you use that extra time for? Try to go over, okay, the stuff that we just talked about. And let me put it this way, okay, is going to be okay, more productive at this time, okay, when I give you guys your break. That, okay, yes, you want to, okay, prepare a cup of tea or coffee or whatever it is, a snack or but at least take it, okay, because it's not that many, it's hardly 1.5 page. And most of your pages are empty. So it's just okay, just 3/4 of a page. So and since we just talked about it's relative, you can say, okay, it's going to be relatively fresh in your heads. So that's why it's okay, you should ask once we are done. It's okay, once we come back, I say, okay, I came across this thing here. Although we just discussed it, yes, okay, although it's okay, I try to read through it, but it still doesn't click. Did that make any sense? So if it doesn't click, if a unit is just floating on top of your head and you're not really getting it, well, okay, I have no problem, yes, okay, explaining it again. Or when you say, well, okay, I got no questions, then okay, that's okay. No question. That means that's okay, either you got it. So then, okay, yes. As of course, this is not what you've been doing on a daily basis, right? Okay. But that's why it's okay. I try to just okay integrate day-to-day things. Cause okay, it means yes, okay, this comes down to yes, okay, the concept. So yes, okay, if you are able to yes, okay, at the end of the day, yes, okay, establish the link between power, between intensity, and between amplitude, for instance, here. Okay, yes, we got it. Okay. So far, any questions about amplitude? Then?
I have a question. For when they decrease, does the amplitude have to be a fraction for it to decrease for the other two
My
too?
dear, listen, okay, whenever we say decrease, okay, Yes, okay. It will be the fraction in the sense that you say, well, okay, what I started was let's say it's okay, an amplitude of 5. Now I'm left with an amplitude of 2.5. So it's okay, it decreased to the half. That makes sense? So whenever you chalk decrease, it can either be written as a fraction. And as I said, on the first day, fractions can also be written as decimals. So 1/2 is going to be 0.5. Did that make sense? Okay. And when you talk about as okay, fractions of just okay, which are multiples of 10 or fractions of tens, you can actually go as okay and express it in okay as 10 raised to the power minus any number. We just make it okay, it's a tenth, 100, 1,000, a million, a trillion. Yes, my dear.
So if amplitude decreased, like I know in our examples, we put by half, by a third. So if it decreased by a whole number, would intensity and power decrease by a whole number? Or it's not going to decrease by a whole number?
But my dear, look, okay. What do you mean by, okay, listen, whenever you is okay, you can say it's okay, the value, that's a whole different thing, okay? You can say it's okay, the value of your amplitude, and that's why I says okay in the question that I wrote, yes, okay, me here was, that okay, the value of your amplitude was initially 6, and it got 5, or it got 12. Here it actually has okay increased twice. Did that make sense? If you just take the amplitude the other way around and say it's okay, or let's say it's okay, initial amplitude was 12. Clear? Okay. And we can say okay, or final amplitude is, let's say it's okay 4. What happened? I hope everybody will agree that okay, yes, 12 is a greater number and 4 is a lesser number, right? Did that make sense?
Yes.
Good. Right, okay. Okay. But what you mainly say is okay, if you start off with as okay, if you start something is okay with 12 and you end up with 4. Okay, what is going to happen? We can mainly say okay, this is going to be as okay 1/3 of this okay what we started with, right? Okay, your final amplitude is going to be 1/3 of what you started with, right?
Yep.
Did that make sense?
Yes.
Good. Now you yes, okay, in this case, yes, okay, you may say that okay, yes. So what about yes, okay, for instance, okay, the power. How is that going to yes, okay, change? Well, of course, since yes, okay, amplitude decreased. Well, okay, so is it that your power is going to decrease? But the question is, okay, as how much? And that's when we say as okay, to determine as okay, how much your power is going to increase. That's the way you have to just okay, look at the how much your amplitude changed. And that's going to just okay, b squared. Of course, that's okay, your power is then going to just okay. So that square remaining means okay, 1/3 multiplied by 1/3, which becomes 1/9. So your power actually is going to just okay reduce to 1/9. So if in this case, yes, okay, because yes, okay, that we have an initial power of, let's say, it's okay, 18 watts. Okay. Your final power is going to, yes, okay, be reduced. Yes, okay, that 18 watts is going to be reduced to 1/9 or 1/9. So our final power is going to, yes, okay, just be 2 watts. Did that make sense?
Yeah.
Clear? Okay. So reduce is always going to be, yes, okay, a fraction. Clear? Okay. But please keep in mind, yes, okay, that fraction can also be expressed as a decimal number. Okay. And in some instances, okay, of course, it's okay if that reduction is going by tenths. It's going to be 1/10, 1/100, 1/1000, 1/10,000, 1/100,000, 1/1,000,000, and so on. But where those fractions also can be expressed as decimals, or since they go by tenths, it can be as okay 10 raised to the power minus whatever exponent. Did that make sense? Right, okay. So if we put it this way, let's just do as okay one side where we say as okay. Where we say as okay increase. And the other side is okay, we say decrease. So I think as okay can increase, we can say as okay and can increase twice. Let's say it's okay, the opposite of increasing twice is half. I think can yes okay increase 4 times. The opposite of that is going to yes okay decrease to 1/4. Did that make sense? You can say, yes, okay, something yes, okay, may increase 5 times. On the opposite hand, is okay, that would mean is okay, mean that okay, as it decreases to 1/5. Now we can say, yes, okay, something yes, okay, may decrease or increase 10 times. On the other hand, yes, okay, that would mean that okay, as it decreases to 1/10. Now this 1/10 here can also be written as this or this. We may say, well, okay, yes, something can also increase, let's say it's okay, 100 times. Where decrease by 100 times would mean it's okay, this, which will be equal to this, which will be equal to this. You go 1,000 times. But the remaining mean is okay. On the decrease side, that would be like this. Decrease to 1,000. Where this mean is okay will be the same as this. Or this. This 1,000 here could also, yes, okay, be written as this. Likewise, 100 could also be written as this. Did that make sense? Okay, so when you say as okay, something reduced, that mainly means that you're just left with a fraction or a part of, okay, that's what you started with. Did that make sense? So that's I say as okay, you start your day with $10. By the end of the day, well, okay, you only got $5 in your wallet left, right? What you use those other $5 for, that's not the question here. We are just talking, okay, how much money is okay, how do you compare the money that you started with on the day to just okay, what you have at the end of the day. So what happens? Your money is reduced to half. Okay. Did that make sense?
Yep.
So that's always going to just okay, you can write that as okay, yes. Reduced by 1/2 or 0.5 or whatsoever. Whereas if you go the other way around and say, well, okay, well, I started my day with $10, but at the end of the day, it's okay, I got $20. Of course, it's okay, then your money would have increased. You just say, okay, it doubled. You multiply by 2. Okay. Yes, Angelis, did that make any sense? Or did that answer your question, dear?
Yes.
So when you say yes, okay, thing is reduced, well, okay, yes, you are left with a part of what you started with, right?
Yeah.
Okay. You can say it's okay, before the wedding starts, there's a full wedding cake, right? Clear, okay. You may say it's okay, once the guest has attacked that wedding cake. Okay. You may just be left with 1/10 of that cake. Or half of that cake. Or whatsoever. Clear, okay. So what is that going to be? You can say it's okay, reduced to half. Okay. It was a 10-cheer cake, now I'm only left with 5 cheers. Clear, okay. There you can say, well, okay, yes. The gifts on the, oh, yes, okay, yes, okay. People, yes, okay, will drop off the gifts that they bring has increased. You might have started, yes, okay, the day with like, yes, 5 gifts that you have put on that table. Just to, yes, okay, stimulate the guests who come. Just, okay, oh, people brought gifts, we probably, yes, okay, you bring something as well. Okay, and by the end of the year, yes, okay, you start off with 5 gifts, or okay, by the end of the year, you have 50 gifts. So you can say, okay, the number of gifts increased 10 times. Right? Okay, but that increase is not going to be fraction. Okay, unless it says, okay, it increased by a fraction of the original, but that's a little bit too complicated to go into those details. Okay, so decrease is always either going to be, okay, a fraction. Fraction can also be expressed as decimals. Okay, and if that decrease is tens or greater, that can also be written as 10 raised to the power. Then that exponent is going to be a negative, because that negative mainly is, okay, indicates that this is either a decimal number or a fraction. Did you guys get that? Anybody else?
Mike, I have a bit of an off-topic question. It's about something from earlier. Can I still ask it?
If you can what it?
I have a question from like some of the earlier material. I just meant to ask it and I forgot. Can I ask it now?
You can ask it whenever, my dear. There's no deadline for asking.
Okay, so if on the quiz, let's say you were asking if frequency could be adjusted and it was like a true or false or whatever.
Mhm.
In our book and as we spoke, it's usually not adjustable unless it's on a newer transducer, right?
Yeah, but okay, my dear. Well, okay, it would not be asking you a transducer. That's okay. The wording more likely will be as, okay, using the same system and transducer. Then in that case, that's okay.
It would be false, right? Then you'd say no, it can't be adjustable.
Yeah.
Okay, thank you. That was my question.
No problem. But practically, let's put it this way. Practically, it's okay. Can you adjust the frequency? Yes. Okay. That's where you come to broadband and all those things. You know what that is, but the other girls don't yet. Okay, guys. Now, what I now can offer you guys is take half an hour, read through your power period, frequency and wavelength, read through your power, intensity, and amplitude, and the relationships, the units. The more information about this and the more information about that. Clear? Okay. And when we come back, yes, okay. If you got any questions, please. Yeah, okay. So would it be fair that I see you guys at, should we say, 11? Let's do 11:30. That's fine. It's a lot of things, much cheaper. So we can have, okay, as a half hour, it's okay, question answer session. If somebody has any questions.
So what time do you want us to come back?
11:30.
Okay.
So you got 40 minutes plus minus. Yes. Did anybody come across something that they want to clarify? Nothing? Okay, then we can have a rapid fire then. So what would be the frequency if your period is 1 microsecond? Then 1 megahertz. Okay. What would be the period if your frequency is 2 megahertz?
2
2
microseconds.
seconds.
No.
One over 2 microseconds.
Or what would be an easier way of saying 1 over 2?
0.5.
0.5 or 0.5 or 1 over 2 of anything is
Half.
half. Half a millisecond, right? Okay. Or microsecond. Did that make sense? How is wavelength and amplitude related?
They're not.
They're not, so they're unrelated, right? Okay. Okay. Good. So what would I mean? You can increase or decrease the amplitude as much as you want to. It's not going to have any effect upon the wavelength. Okay. How is period and frequency related?
Inversely.
Okay.
And reciprocally.
Reciprocal is a better answer, right? Okay. Okay. Reciprocal automatic will mean that they are inversely. Yeah, okay. So that's just, yes, okay. Killing 2 birds with 1 stone. Okay. Now, what does it mean to be ultrasonic? If you see a sound wave is ultrasonic, what would that mean?
Greater than 20 kilohertz.
Greater than 20 kilohertz, right? Okay. Okay. What would be another way of saying 20 kilohertz? If I say I don't want you to hear, yes, okay, kilos, millos,
20,000 hertz.
20,000 hertz. Okay, good. So how many cycles do you have in a second then?
Can you say that again?
How many cycles would you have in a second then? If you have a frequency of 20,000 hertz.
20,000.
20,000, right? Okay. Yeah. Uh-huh. Good. What would be the wavelength of a sound wave in soft tissue?
1.54.
Hold on. If the frequency of your transducer is 2000 kilohertz, your transducer's frequency is 2000 kilohertz, what will be the wavelength of the sound wave?
0.77 millimeters.
0.77 what?
Millimeters.
Millimeters. Why?
It's 2000 kilohertz equals 2 megahertz.
2
And
megahertz. So
divided by
1.54 divided by the frequency in megahertz is going to give you the wavelength in millimeters. Okay. How is power and amplitude related?
Directly.
Directly. Good. Okay. What is the unit for intensity?
Watt?
Say
Watts?
watt per centimeter.
Centimeter squared.
Okay, can anybody define intensity?
The concentration of power over area.
Exactly. So from that, you just, okay, power per area, that's where you make your unit, right? So the unit is in the definition itself. So it's going to be power is watts, area is any unit of distance squared. Did that make sense? It can be meters, it can be millimeters, it can be centimeter, that doesn't matter. Okay, you just increase or decrease the area accordingly. Okay. How is intensity and volume related? How is intensity and volume related?
Are they unrelated?
They're unrelated. Okay. Okay. Intensity is inversely proportional to area. Density is inversely proportional to volume. Clear? Okay. But intensity or density is directly proportional to
Mass.
mass. Good. And what do we mean by mass? Or what is the unit of mass? Let me put it this way.
Gram.
Kilograms. Yeah.
Grams, kilograms, milligrams, nanograms, micrograms. Okay. What do you call 1,000 kilograms? Although it's okay. What do you call 1,000 kilograms?
Are you asking what it would be in grams?
No. What do you call 1,000 kilograms? If something weighs 1,000 kilograms, what would that be? It
A
would be
ton?
a ton.
A ton.
Did that make sense? Okay, now I can ask Caitlin then. How many grams do you have in a kilogram?
1,000 grams in a kilogram.
1,000 grams. Okay. Now, how many milligrams do you have in a gram? How many milligrams do you have in a gram?
1,000.
1,000. So how many milligrams would you have in a kilogram? What's 1,000 times 1,000?
Is it 100,000?
No.
You're putting me on the spot, Mike.
No,
I
I'm
can't
not putting
do
anybody in
decimal
the
points
spot.
this fast.
What is 1,000 times 1,000? If that's 100,000, I have $100,000. I want to give it to you and give me yes, okay, $1,000 bills. I give you 100,000. I walk home with 1,000,000. So 1,000 times 1,000 is
2,000.
1,000 times 1,000, not add.
A million.
1,000 times 1,000.
Yes. Equals what?
10,000?
Um,
No.
Million?
a million.
It'll be 1,000,000.
Oh God.
1,000 times 100 is 100,000, guys. What is 10 times 10?
100.
100. Okay, 10 times 100. 10 times 100.
1,000?
1,000. Okay, good. Okay. 10 times 1,000. 10 times 1,000.
10,000?
10,000. Okay, 100 times 1,000.
100,000.
100,000?
100,000, which is 1/10 of a million, right? And now you say it's okay, 1,000 times 1,000 is 1,000,000. And then you can go as okay as okay, 10,000 times 1,000 is 10 million. And then you go on. 100,000, 100 times 1,000 at 10,000 is, and so on and so on. Have fun with that. Goody moody booty. Now, what happens to the amplitude of a wave as it travels through medium?
Decreases.
Decreases, right? Okay. So what you will be left with at the end of that journey is going to yes, okay, just be a portion or a fraction or a decimal part or a small fraction of what you started with. Okay, so that's why they all will be as okay. And then they say, okay, how much compared to yes, okay, where you started with, that will be written as a fraction or a decimal or expressed in decibels. Clear? Okay. So decibels is mainly going to be as okay, comparing initial versus final. What you started with compared to what you ended with. Clear? Okay. And it's going to be as okay, guys. I already told you it's going to be as okay, a unit that will be used again and again and again and again and again and again. Okay. So from chapter 6 to chapter 15. On my 15. 16. You will see nothing but decibels popping up here and there. So is there anybody who is in any doubt about that? So it's mainly just okay going to be a comparison between the job start or beginning, or start versus end versus start, whichever. Clear? Good. Now, how is speed of sound related to wavelength? Speed of sound related to wavelength.
Higher speeds mean longer wavelengths.
Okay,
So directly.
okay, but then how is wavelength related to speed?
It doesn't affect it.
It's not that would be unrelated, right? Okay. Clear? Okay. But frequency is inversely proportional to wavelength, but not reciprocal. Clear? Okay. Okay, so you can't say that, okay, as the wavelength of a sound wave with a frequency of 2 megahertz is going to be half a millimeter or something like that. It's just inversely proportional. That the greater the wavelength, that's okay, the greater the frequency, the shorter the wavelength, but not reciprocal. That reciprocal only applies for period and frequency. Anytime it's anything measured in terms of time and how many times, that's okay. That even occurs in a period of time. Good. Now, if your amplitude increases to twice the initial value, sorry, what is going to be the change in your power?
Four?
It increases 4 times. Yeah, okay. If your amplitude decreases to 1/3, what's going to be the change in the intensity?
You would multiply it by 1/9.
Okay. So it's going to decrease to yours. Give me the answer, dear. Just it
So
has to
1/9.
it has to decrease to 1/9. Or it's going to just okay decrease by to 1/9. Okay. That makes sense. Okay. So for us, okay, things like that is okay. You may have to yes, okay, need a initial intensity or initial power to determine yes, okay, what the final power or intensity will be. Okay. But that's okay. Those comparisons, guys, okay. I think I wrote them pretty well. Like here. Okay, guys. Yes, guys. So any question that you guys want to ask? No. Nope. What is reciprocal to giga?
Nano.
Nano. What do we mean by rarefaction?
They're farther away. The molecules are farther away. They aren't as compressed.
Particles or molecules are far away. Okay, good. Okay. Okay. What kind of energy is it that sound is?
Mechanical.
Mechanical. Okay. Okay. What does it mean to be a transverse wave?
The particles move up and down and the wave moves across.
Move across. So you guys says, okay, the direction of the particle motion and the direction of the movement of the wave is perpendicular or across one another or transverse. Right? Okay. When do we see constructive interference?
In phase waves.
In phase waves. Okay, good. What does it mean to be in phase? No, not you, Kristen. Somebody else. Let somebody else. Sorry. What does it mean to be in phase?
When the amplitudes happen at the same time, they're just different heights.
Okay, they can be of different wave amplitudes, right? Okay, they don't have to be of the same amplitude. Okay, but you can say means that's okay when they reach the same point at the same time. Okay, we may know me as okay that they will have their peaks at the same time, they will have their troughs are at the same time. Yeah, okay. So what is going to be the result of a constructive interference?
A higher end wave, like a bigger.
Or when you say, okay, a bigger wave, how would you rephrase that in more physics-related term?
Bigger amplitude.
A wave with a greater amplitude, right? Okay. Okay. It means says, okay, now how do you get those bigger amplitude? It means, okay, because the power of the one wave and the other wave are added together, right? Did that make sense? Clear? Okay. All right. So something, yes, okay, which in the beginning might not have made sense because, okay, we didn't talk of power, we didn't talk of intensity, we didn't talk of this, we didn't talk of that. That's okay, may start making more and more sense when we proceed because we get introduced to some newer concepts, or as I say, more juicy details. Which then, yes, okay, you can say, it's okay, clarify as okay, some older concepts. Okay, that we have discussed. Although it's okay, they might not be that clear at that time. It's just a little bit, that's okay, foggy. Okay. Okay, guys, now you guys take your lunch break. And when we come back, we will talk about propagation speed. The last of our 7 parameters. Okay. So what determines your period? Come on, guys. What determines period?
Your source.
Source. Okay, good. Okay. What determines wavelength?
Both.
What's both?
Medium and your source.
Medium and
The source.
source. Okay, good. What do you call the source?
Transducer.
Transducer. What do you call the medium?
Tissue.
Tissue. Good. Guys, so I see you guys no later than 12:45, okay? So that's okay. So we talk about speed, factors of that affect speed, and that's okay. So and so.
We're gonna start on page 36, right?
If that's what
Propagation speed.
propagation speed, exactly.
Okay.
So 12:45, okay? Okay, guys, see you then. Okay, guys, now before we get started, any questions? Nope. No questions? Good, but let's see what we got then. Okay, guys. So what we can say is that the last parameter, or acoustic parameter that we'll talk about is going to be the propagation speed. Okay, and please just keep in mind what is the speed tells us. It is going to be okay, how fast or slow is it that an object is moving. Okay. Whereas propagation is okay, just a fancy word for progress or ahead or proceeding, if you want to put it that way. Yep, okay. So your propagation speed of RV media is okay, we'll say it's okay, will be as okay, the speed of sound is mainly going to be as okay, just talking about as okay. How fast or slow does the sound travel? Okay. Now, guys, as I said, or I've been saying, sound is produced by the source. Clear? Okay. So once I have spoken the word, that they leave my mouth. Okay, it's all going to be dependent upon the speed at which sound travels. That will determine what is the interval between me uttering the words and you guys hear it. Did that make sense? So that's going to be determined by how fast is it that the sound travels in? What is between my mouth and your ears, which will be the medium. So we can mainly say how fast or slow is it that the sound travels in a medium. Now this, how fast or slow? And mainly it's okay because it's okay to travel. Mainly it's okay is going to make up the unit of speed, which we mean can say it's okay. That is going to be okay and made up of any unit of distance or yes, okay, we can say it's okay, any unit of time. Yeah, okay. So the unit of speed, or in this case, as okay, propagation speed is going to be made up of any unit of distance or unit of time, which we as okay, just for instance, can say as okay, would be meters per second. Okay. Now there's no rule that said that you can't take, and you don't, either you can't say it's okay, millimeters per second. You can do that. Okay. You can even as okay, go from meters to second and say it's okay, what about kilometers per second? It's fine too. Okay. You can even go as okay, from meters to as okay, per microsecond or millisecond, whichever. Okay. But the only thing is that okay, as distance is going to be the numerator, time is going to be the denominator, or the unit of speed. Did you guys get that?
Yep.
Good. Now, before talking about, yes, okay, the typical value of speed here is okay. Let's just, okay, yes, get that clear that, okay, yes, that, okay, yes, our propagation speed of sound here is determined by the medium. And let's just say it's okay, medium only. Did you guys get that? Okay. So whatever the period of the sound is, or let's say it's okay, whatever the period of the sound wave is, or inversely, it's okay, whatever the frequency of the sound wave is, that is not going to just okay have any effect on whether that sound wave travels fast or slow in the medium. Because you can have high frequency sound wave that travels slow. You can have low frequency sound wave that travels slow. You can have high frequency sound wave that travels fast. And likewise, yes, okay, you get low frequency sound wave that travels fast. Because what is going to be the main determining factor of how fast or slow a speed sound travels is the medium. Clear? Okay. Now, as far as the medium was concerned, we already, okay, back in chapter 2, I mentioned the general rule is travel fastest through solids, slower through liquids, and slowest through gas or air. Did that make sense? Clear? Okay. So that's why we as okay, meaning as okay, and I was going to be as okay, the nature of medium. You may have media or tissues which will be solids. You may have tissues that maybe you can say it's okay, less solid, semi-solid. You may have tissues which are liquid or media which is liquid. And you will have tissues or media which is going to be made up of, or made as okay, holding on to air. Did that make sense? So that roughly tells us, okay, in which medium is it that the sound is going to be fastest, then slower, then slower, then slower, then slower, until you get to the slowest. Okay, so it's not the period, it's not the wavelength, sorry, it's not the period, sorry. It's not the frequency, it's not the power, it's not the intensity, it's not the amplitude of the wave that will determine the speed by which a sound wave travels. It's going to be the medium. Okay, okay. So two waves with different or let's say it's okay, same frequencies. But if they travel through different medias, it's going to be traveling at different speeds. Clear? Okay. This is the one that you most likely is okay will get caught on or fooled by. Clear? Okay. Okay. So no matter what your frequency is, no matter what your frequency is, high or low, they both will travel through the same medium at the same speeds. Did you guys get that? So it's going to be the medium and the medium only. Or we can say, okay, the nature of the medium that will determine the propagation speed.
Can you say that first part again? No matter the frequency,
No matter the frequency.
they'll
But if
travel
the
at the
sound travels through a similar medium, they will have the same speeds. Clear? Okay. You can have different frequencies. But if that sound is traveling through the same medium, it's going to be traveling at the same speed. So my guys, no matter how you twist or turn it, your sound waves propagation speed is going to be determined by the medium, or let's put it this way, by the nature of the medium and the nature of the medium only. Did you guys get that? Clear? Now, although we say it's okay, it may be related, or you can say the propagation speed may be related to the wavelength, but that's going to be the faster speed will cause a greater wavelength, and lower speed, lower wavelength. Clear? Okay. But the wavelength is not going to affect the speed. Did that make sense? So it's a one-side traffic between, yes, okay, speed and wavelength. That's only the wavelength that is going to be, yes, okay, affected by the speed and not vice versa. So speed affects wavelength, but wavelength does not affect speed. Did you guys get that?
Yeah, so does
Okay.
that mean there's no relationships between speed?
Well, you can put it, my dear, you can, and that's why I said that speed affect wavelength. Clear? But wavelength does not affect speed. Clear? Okay. Now, guys, your typical value for propagation speed. Now, guys, what we have is, okay, we have a long list of different types of media or tissues. Is that clear? Okay. We have a long list of different types of media and tissues. You have lung, you have fat, you have blood, you have urine, you have liver, you have muscles, you have tendons, you have bones. All different kinds of tissues. Okay, with different, what the hell you call it, propagation speeds. But the only speed that you actually will need to remember is that of us, what I mentioned yesterday is a kind of tissue that we don't find in anatomy books, but mainly is designated only for the purpose of explaining as talking, ultrasound, and that was what we call soft tissue. Did you remember that one? Okay, guys. Now, when we talk about the soft speed of sound in soft tissue, now that is actually the only value. That says, that's actually the only typical value of sound propagation speed that you need to remember. So, guys, in soft tissue, the propagation speed of sound is 1,540 meters per second. Is that clear?
Yep.
Yep.
Okay. So this is actually 1,540 meters per second. Or this value can also be 1.54 millimeters. Let me just write that a little bit more clear. Per microsecond. Did you guys get that?
Yes.
Good. Now, guys, please, let's just do it this way, guys. Okay, come on, guys. Okay. What does this 1,540 meters mean? That's mainly we can say approximately 1.5 kilometer in a second. Or roughly speaking, if you want to put it that way, you can say the sound actually is able to travel up to 1 mile in a second in soft tissue. So if you have 1 mile of soft tissue, 1 mile of thickness of soft tissue, it will take the sound wave 1 second to travel from one end to the other end, because it travels at a speed of 1,540 meters per second. Did that make sense? Now, you're probably not going to come across a person who is going to just, walk into the room with, has 1 mile of soft tissue. If that's the case, well, okay, yes, you probably also need, yes, okay, a 1 mile ladder to climb before you're able to, yes, okay, place the transducer on his or her belly or whatever area that you're going to be scanning. With that person, that's okay, either standing up or lying down or so. Clear, okay. But just so you guys, okay, as can see, it's okay how fast it travels in soft tissue. And that's going to be as okay in the intermediate speed. Is that clear? But guys, of these two values, although yes, okay, they are the same. They come out to the same. But I just want you guys to, yes, okay, let's say it's okay. Look at this one here. Okay, because these were actually, as okay, the numbers. And yes, okay, directly or indirectly, yes, okay, the units that we used or talked about yesterday or the other day when we say wavelength. Now I may, yes, okay, I may know that, okay, it may be, yes, okay, a little bit flipping back and forth. But if you just go to page number 35 and look, and we said, for instance, yes, okay, we said, what was the formula of wavelength? And I mean, yes, okay, just to make sure that, okay, as we held the unit for wavelength, yes, okay, it was going to, yes, okay, be calculated in millimeters. But what did we say the formula was? 1.54 millimeters. Where did you get this 1.54 from? From the propagation speed, right? Okay. Did that make sense? Right, guys?
Yes.
Good. And we say, okay, maybe that's okay, propagation speed is okay from the sound off, sound in, soft tissues. Because that's where it's okay. This number here actually came from, it's okay, from the speed of sound in soft tissues. Okay. But then we say it's okay, that was going to say it's okay, be divided by a frequency, right? Clear? Okay. But this frequency is okay, what was that going to be expressed in? In megahertz. Right? Right, guys?
Yeah.
Good. Now, why megahertz? Because, okay, here the unit for the time was microsecond, which means 1.54 millimeters in each microsecond. And what we as okay would know is that mega and micro are reciprocals. Which means as okay, million times in a second. Did that make sense? Did that make sense?
Yep.
Anybody who is in doubt? Okay, so that's why it's okay. 1.54 here is okay. With the unit millimeters is going to be as okay because it's okay, the constant number. Well, please keep in mind, guys, that okay, this only as okay applies for soft tissues. Okay, but as far okay, the propagation speed is concerned, you only need to remember is okay what the propagation what the propagation speed of sound is in soft tissues.
So we don't need to know the range.
Well, if you want to, 500 to 4,000, right?
Yeah.
Okay. Okay. But we can say is okay, that of soft tissue is somewhere as okay, pretty much okay as in the middle between as okay, we can say it's okay, the slowest and the fastest, which was 500 to 4,000. Yeah. Okay. Somewhere is okay, closed in the middle between the two. Okay, but you don't necessarily as okay, my dear, need to remember the range as long as you know the speed of sound in soft tissues.
Okay, thanks.
That's the value that you are expected, required, supposed to know. Clear? Any questions? So whether you go and say it's okay, 1,540 meters per second, or whether you say it's okay, 1,54 millimeters per microsecond. They are both the same. Or worth the same. Okay, but that 1.54 with the millimeters and okay per micro, yes, okay, also help you to yes, okay. We can say it's okay, clarify as okay, why is it that 1.54 is the constant number in our wavelength formula? Okay, where you divide it by frequency in megahertz. Okay, clear? So the frequency has to be in megahertz, and your wavelength will then be yes, okay, calculated in millimeters. Okay, guys. So now in your book, when it talks determined by, although I already talked about this, but yes, okay, you see that it has two paragraphs. Okay, the first reads that the speed is determined only by the medium through which the sound wave travels, right? Okay. Okay. Speed is not affected by the nature of the sound wave. What that means here is things such as period, frequency, intensity, power, blah, 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 blah. So these are all unrelated to the propagation speed. Yeah. Okay. So you get a question that says, okay, you have two waves with these and these powers, different powers, traveling through a medium. Which of the two is going to just, okay, be traveling fastest or slowest? Well, okay, they're going to be traveling at the same speed. Now, please keep in mind, provided that it's the same medium that it's talking about. If it talks about two waves traveling through different mediums, it's going to be, okay, the medium with the greatest speed that will travel, through which it will travel fastest, and slower speed that it will travel slowest. Irrespective of, okay, as whether those powers were in same or different. Did you guys get that? Okay, so
Yep.
that's okay. The other parameters of sound, that's okay. Sound wave is not going to affect your propagation speed. It's just the medium through which it travels. Clear? Okay, so only the medium will determine the propagation speed. Clear? Now that following paragraph that says, okay, so all sounds, regardless the frequency, okay, travels at the same speed through a specific medium. Which will mean that if you have a certain medium, you can say bone, for instance. Okay. You scan a bone, or okay, a sound wave, that's okay. Travels through, that's okay, a bone, but that's okay. You have, okay, two sound waves with two different frequencies. The sound is going to be traveling through that bone at the same speed. Although that's okay, you had different frequencies, you might have had different wavelengths, you may have had different, what the blue we call that fellow? Periods, you might have different power, intensities, amplitude, so and so and so. The speed that the sound is going to be traveling through is the same. Clear? Okay. So please mark this paragraph here. As I told you earlier, it's okay. This is the one that they will try to catch you on. And you can't come back and say, well, okay, where is that written in the book? It's written there. Okay. So please mark this, highlight it, whatever you want to do. Just okay, make you. It's okay, people. Just okay, cast the attention for this one here. So as long as the medium is the same, the other features of a sound wave can be as far different from one another that you can think of. That's not going to affect the speed at which the sound will travel. Did I make myself clear? So it's going to be the medium, or we can say, okay, the nature of the medium that will determine whether the sound travels fast or slow. Did you guys get that? Good. Now, can you adjust the speed? No. Why? Because it's not in your control. Yes, okay, what tissues are going to be in the pathway of the sound as it travels. You can't tell the sound very well. Okay, yes, you know what? I know that you are known to travels fast through solids, slower through liquids, and slowest through air or gases. Just change that. Fast, travel fastest through air. Okay. And slower through solids and slowest through liquids. That's not how it works. It's going to be the medium through which the sound travels that will determine that. Okay, so you are not able to adjust the speed. We're just going to just, okay, change the speed all dependent upon as, okay, the medium that it runs through. Did you guys get that? Any questions? So guys, the nature of the medium will determine the propagation speed. And that's not something we can change upon. We don't have a knob that we can rotate and increase the speed or decrease the speed. Did you guys get that? Clear? Good. Now, my dear guys, on page number, tick, 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 what is it? 37. Page 37, right? You guys have your books? Okay, guys, and on page 37, you may see as, okay, where is labeled as table 3.3, where we have two things. You can say, okay, we have tissue type. And then we have speeds. And the speeds given here is going to be as, okay, using as, okay, meters per second. That's fine, just to document it. Okay, guys, and then we have, okay, yes, longer or smaller list of tissues. We have a lung, we have fat, we have, okay, yes, the soft tissue. Then we have, okay, yes, liver. Then we have blood. Then they go, yes, okay, muscle. Then they go tendon. And then they go bone. Okay, where you mainly will see here is, okay, it says, oh, 500 meters per second, sorry. Okay, it goes as, okay, 1450. Then, okay, as for the soft tissue is this. Then it goes as, okay, 1550. Then it goes 1550. Then it goes 1600. Then it goes 1700. And then it goes 3500. Now, guys, out of all these values here, it's okay. Only one to remember. Yeah. Only the speed of soft tissue is just, okay, what you need to remember. Did you guys get that? So for the rest of these, as far as the values are concerned, Hakuna Matata. Did you guys get that?
Yeah.
Good. Then some of you may be scratching your heads and saying, now why in the hell would the author give us this list of tissues here with their speeds? If you only actually remember that of the soft tissue, you could just have sufficed that, okay, yes, the diagram, or sorry, paragraph above. But guys, okay, you have to remember this sequence here. Where you mainly will say, it's okay, now this here is okay, slowest. And down here is okay, it's the highest. Okay. Now, although yes, okay, although here they say lung, but actually it's okay, what they actually mean is, sorry. It's for ear. Okay. But this sequence here is okay, that's what you need to remember. Okay, whether you start from long and go, yes, okay, from slowest to fastest, or if you want to go from this to this, it's up to you. Clear, okay. But that's okay, if you go in this direction, you can mean it says, okay, that's going to be as okay, the speed in and increasing order. Because, okay, you start from the lowest and get to the highest. Clear, okay. Whereas, okay, guys, if you go in the opposite direction, like this, that is in the decreasing order. Maybe yes, okay, because you go from the highest and end at the lowest. If you look at the speeds, you go from the highest speed and you get lower, 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 lower. Did you guys get that? Okay, so the only actual speed that you got to remember is that of sound in the soft tissues. Did I make myself clear? Now, those of you who don't like to remember, it's okay, a lot of typical values, and take a sigh of relief. Earlier, somebody said it's a lot of typical values. I go, okay, well, let me see if I can remove something for you. Okay. Okay, dear. You can talk about the second table. That's okay. We already talked about that. Okay. Air, gas, water, liquid, and solids, or metal is solids. Are you going to be asked about it? Okay, what is the sound of speed in metal? No, because we're not going to just okay conduct ultrasound scans or gun safes or things like that. Or that's okay, ships or motor cars or so and so. Did that make sense? But that's okay if you scan a glass of water or you can say it's okay. If you scan water versus, yes, okay, a steel nail, the sound is going to be traveling through that steel nail at a greater speed or faster than it travels through water. Right. Good. Any last words of wisdom? So far, how is speed going? Good. Cruising on the highway, giving that thing gas. Okay, guys. So what is it I've been saying? No of the other parameters of sound waves, okay, affects the propagation speed. Right? Okay. I said only the nature of the medium, the nature of the tissue will determine your propagation speed. Did you guys get that? Okay. Now, as far as that is concerned, yes, okay, we can say it's okay, the nature of the medium. Or it's okay, what characteristics of the medium is okay, may determine the propagation speed. And as many as okay going to be as okay, two factors. One is going to be as okay, the stiffness of the medium or tissue. And the other one is going to be as okay, the density. Okay, and just to just okay, be more clear, because that's okay, the density of the medium or tissue. And okay, yes, the stiffness of the medium or tissue. That's mainly is okay what to talk about. Did you guys get that?
Yeah.
Oh, guys, the question comes, what the is stiffness? Now, guys, stiffness is probably as okay a term that maybe as okay, you can say a little bit difficult to explain. No, not real difficult, but like okay. Or you can mainly say as okay that that's going to be as okay the inability to get compressed. So you can say as okay the or to be more, you can say as okay, it's going to be the opposite of flexibility or elasticity. Is going to be stiffness. Did you guys get that?
Can you read what it says in the purple? Inability to.
Inability to get compressed. Clear? Okay. Or we can say that, okay, stiffness is going to be as, okay, the opposite of flexibility. Or you may say that, okay, stiffness may as, okay, be the same as rigidity. Or rigid, or unbendable, an object or a substance, or in this case, as, okay, a tissue is going to be. Did that make sense? Now, have any of you ever played ball?
What kind of ball?
Now, we can talk
Baseball,
about kinds of
basketball.
balls. Okay. Let's say it's okay. What do we have? We have a basketball ball. Clear? Okay. Comparing that to a foam ball. Clear? Now, they're going to be of the same size. Well, it's okay. Which of the two is it that you would have, it's okay, a hard time to squeeze or compress?
A basketball.
A basketball ball. Why? Because it is more stiff compared to, as okay, a regular rubber ball or a foam ball, right? Okay. Clear. Why? Mainly because it is more stiff or is more rigid or less compressible. Clear. Okay. Now, guys, okay, when you talk about tissues and talk about, it's okay, stiffness of tissues, what's going to be as okay as stiff tissue?
Tendon.
Yeah, okay. But let's say it's okay, what's going to be the stiffest?
Bone.
Bones. Okay. Unless you are Rubber Man. Have any of you heard of that Marvel figure? No? Yeah, okay. He got kicked out of the Marvels because he's going to be replaced by others, right? There's so many. No, they're okay. They can't put them all on one scene. Okay, peace be with that. Okay, but that's okay. Just get a bone of anything. Please don't get a bone of a person and try to bend it. It will break, but you can't, it won't bend. Why? Because it's rigid, because it's stiff. Did that make sense? Good. So, our other criteria. Or other criteria that is okay, or characteristic or nature of a tissue that may, as okay, determine the propagation speed is going to be the density of the tissue. And what was density?
The weight of it.
The concentration of mass per volume. Yeah, okay. It got to be, yes, okay. If you just said weight, my dear, well, okay, the actual the word for as okay in physics, what people as okay may refer to as weight in common daily life is mass. Okay, so it's going to be as okay the concentration of mass per volume will be the density. Now again, yes, okay, let's get back to our balls scenario. But the two balls that I may ask you guys, yes, okay, compare now to one another. is going to be the ball of golf. Have anybody seen a golf ball? Not bigger than this, right? Good. And a ball of ping pong, also known as table tennis. Physically, it's okay when you put them side by side, they are the same size, or you can say it's okay, the same volume. Clear? But when it comes to the density, the golf ball is having a hell of a higher density than the table tennis ball. Have anybody ever got hit in the head by a ping pong ball? Okay, what happened?
It bounces off. It doesn't hurt.
Okay, good. Did you feel much?
No.
Nah, okay, good. Have anybody got hit in the head with a golf ball? Okay, now what happened then?
That hurts.
That hurts. Okay, but if you look at the ping pong ball versus just okay, the table, oh, sorry, a golf ball, that's okay. Size-wise or volume-wise, okay, they're the same. But the table tennis ball is on the inside just here. Yeah, okay, the ping pong ball, that's okay. Golf ball, sorry, is, I don't know what the hell they put into that thing to make it so hard and so heavy. Okay, but that's okay, it has a greater density. Did that make sense? Because it's packed with solid, whatever, cement or some sort of crazy, whatever. Did that make sense? Okay, so the stiffness of the tissue and the density of the tissue are going to be as okay two characteristics that will determine whether the speed of sound travels boom, fast through that tissue or slower or even slower. Did you guys get that? Good. Now do we come to the relationships? Yeah. And okay, yes, we can talk about this from now till doomsday. Or we can do it this one here, we can see. But that's going to be as okay, a little cheat as well. So we can say it's okay, speed. How is that related to stiffness? And likewise, that's okay, speed. How is that going to be related to density? And please keep in mind, guys, that's okay. When we talk speed, that's okay. We're saying that's okay. The propagation speed. Propagation speed.
Directly.
Of sound. Clear? Okay. Whereas, okay, as when we talk about stiffness and density, it's okay, that's going to be as okay of the medium. Of the medium. And what we mean by the medium is the tissue. Now, as far as the propagation speed and density is concerned, sorry, stiffness. As far as the speed of sound in a medium and the stiffness of that medium is concerned, these two here are going to be directly proportional to one another. Which mainly will mean that, okay, yes, the greater the stiffness, the greater the speed. or lower speed if the tissue is less stiff. Did you guys get that?
Yep.
Okay, guys, and the cheat is S goes with S. Whereas the relationship between the speed of sound to density of the tissue are inversely proportional. Which means that, okay, yes, if you had, let's just use this one. If you had a tissue with a great density, that will lead to, yes, okay, a lower propagation speed. Or if you have a tissue with that's going to be, yes, okay, a greater speed, that's because of a lower density. That makes sense? So propagation speed is directly proportional to stiffness, but inversely proportional to density. Did you guys get that?
Yes.
So what you will see is, okay, the questions in your exercises may ask about, okay, which kind of medium is going to have the greatest speed or lowest speed? High density, low stiffness, high density, blah, 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 blah. So if they ask about, it's okay, greatest speed, that's going to be, it's okay, greatest stiffness and lowest density. Things like that. Did you guys get that? Okay, now you can say as, okay, now since we have two characteristics of a tissue that inversely as, okay, affects the propagation speed. Okay, which of these two here, okay, plays the major role? Because one will increase, one will decrease.
Stiffness.
It will be stiffness. So stiffness, as you can say, is, okay, have more to say of whether, okay, yes, between the two factors, of whether it's, okay, sound is going to be traveling fast or slow in a tissue. Did you guys, sorry, get that? What day is it tomorrow?
Wednesday.
Wednesday, okay. Midweek crisis. Okay. Now, you can say, so, okay, one good thing about the book here, at least that's okay for this chapter. Okay, a couple of chapters has that. At the end of the chapter, yes, okay, you have a summary, right? Yeah, okay. But why should that summary be as okay? That should just be as okay. You can say it's okay, a tool for you guys to be able to revise your stuff. But only as okay if you are able to as okay fill up the blanks, fill up the empty as okay, the things that are not mentioned. In the summary, if you can fill out all that data, yes, okay, that means that you can say, okay, well prepared, you know this. Or we can have, okay, yes, a brainstorm where it's okay, where somebody may end up having, okay, as a brain fart. And that's going to be as okay, a fart storm. Okay. Good. Now, guys, any questions? So there is just 12 days to Christmas. It should remind you that there's only 10 days for the first quiz. Good. Okay. So, guys, what I would request you guys to do is read through the chapter. Okay, and what we will be doing tomorrow is most likely as okay, going over the questions at the end of the chapter. And we can say, okay, the relevant questions of this chapter in the exam review. Okay. Does that sound like a plan? Good. So, any last word of wisdom, guys? Any questions? So, what is propagation speed? How fast or slow did sound travel? Clear? Okay. What about the unit? Any unit of distance per unit of time. Clear? Okay. What determines it? It's going to be the medium that determines the speed. Okay. The speed may affect the wavelength, but the wavelength will not affect the speed. Clear? Good. Typical value, well, okay, we have a range from 500 to 4,000, but the mean typical value that we need to remember is that of the speed of sound in the soft tissues. Okay, now since that's okay here, it is determined by the medium. Well, okay, we can't adjust it. Did that make sense? Clear? Okay. Generally speaking, as okay, which medium would the sound travel fastest? Would be as okay, solids like bone. Clear? Okay. Okay. You may say as okay, tendon is going to be as okay, more stiff than muscles or more dense, and so on. Clear? Okay. but slowest in it's okay tissues with air. And that's why it's okay is lung. Okay, what the main is okay will mean here are referred to is ear. Okay, then fat, then soft tissues, then liver, then blood, then muscles, then tendons, and then bones. Clear? Okay, now you can make your own mnemonic. An easy way to remember things like this is if you make a mnemonic. Okay, it doesn't have to make any sense. Just like, okay, yes, Big Master King Harry doesn't usually drink chocolate, may moo ah. Okay, it doesn't have to make any sense. Unless you know a King Harry or Henry or whatsoever who didn't like to drink chocolate milk. Okay. So yes, okay, if you want to, yes, okay, go from the top to bottom, yes, okay, you can do that. Or if you want to go from bottom to top, you can do that. Okay, but that sequence is must to know. Whichever. But if you know to count from 1 to 10, you can also count from 1 to 10 to 1. Okay. Did that make sense? Clear? Okay. And the two characteristics or features or natures of the tissue that determines the speed is how stiff is it that that tissue is, and what is the density of that tissue. Clear? Okay. And what's going to be as okay, their relationships to the propagation speed. Capiche? See you guys tomorrow. Okay?
All right, see you tomorrow.
Thank
Okay.
you.
Okay.
Bye.
Okay. Bye-bye there.